Hello, this is Stephen Whitfield with Drilling Contractor. Right now I'm joined by Wiley Long, PDC Bits product champion at Schlumberger, for a discussion on the latest developments in drill bit design, including Schlumberger's own offerings in this space. Mr. Long, thank you very much for stopping by.
Thanks for having me.
Within the wider drilling industry, how new is the use of three-dimensional shape in the cutting elements of drill bits? And what motivated turning the research and development focus to the cutter element for new performance gains from PDC cutters?
So, you can actually find examples of PDC bit and cutter vendors incorporating shape into PDC cutters, even dating back as far as the late 90s, 1990s, or early 2000s. But really back in those days, the process of altering the geometry was typically done by removing large pieces of the PDC cutters. And with the relatively low capabilities of cutter technology available more than 20 years ago, the shapes that they were able to make really proved only useful in a very limited amount of drilling applications. Now, since the turn of the century, there have really been incredible advances in PDC cutter technology, where cutter manufacturers have made great strides in improving the materials and the manufacturing processes used to make PDC cutters. Even since the introduction of cutter leaching in the mid-2000s, we've seen that the improvements in diamond press technology have enabled PDC cutters to dramatically increase their resistance to cutter wear and impact damage. Now, historically, cutter wear and impact resistance to cutter wear are the key metrics by which PDC cutter performance is measured. But the great thing about incorporating shape into today's PDC cutters is that it allows us to create an additional metric by which PDC cutter performance is measured, that being cutting efficiency. The shapes we use in Smith bits to improve the cutting efficiency is really done at a level where the cutter meets the rock. And to better explain this, we can look at Hyperblade, which uses a shaped PDC cutter with a very prominent scooped geometry. Hyperblade bits are used to improve cutting efficiency and improve ROP in soft and plastic formations. And the way we utilize the scoop shape can really be analogous to using a large spoon when you might be preparing yourself a bowl of ice cream. Now, of course, you could use a utensil with a flat face to get your ice cream, but it would be much less effective. And it's the same overall effect that we're applying to our portfolio of shaped PDC cutters, ensuring that our cutter geometries are the ideal shapes for the rocks which are being drilled.
I understand that your Stratablade drill bit features a new concave diamond cutting element. Can you tell us about the element and the bit, particularly the unique geometry of the cutters?
Sure. When we kicked off the Stratablade project with our engineering team, we already had quite a diverse portfolio of shaped cutter technologies available with products like Hyperblade, Axeblade, Stingblade, and EnduraBlade 360. Now, each of these cutting technologies is targeted to improve performance for specific drilling challenges. And when we looked at our portfolio at the time and reviewed where the biggest gap remained for using a shaped PDC cutter, we found that the application space residing between Hyperblade and Axeblade was the widest. There was not yet a cutter shape to improve cutting efficiency in those medium strength formations between 5,000 and 20,000 PSI of unconfined compressive strength. So since we are targeting drilling applications between Hyperblade and Axeblade, it made sense for us to include and combine some of the geometrical features that have made each of those successful. With the Strata concave diamond cutting element, we've used a ridge tip similar to that of Axe, because we know that being able to concentrate point loading onto the cutter tip helps with maximizing the depth of cut. And then, taking a page out of our Hyperblade learnings, we include a concave feature on the face of the cutter to reduce the effective cutter back rake and increase cutting efficiency when drilling through medium strength formations. Finally, to ensure that the cutter strength is maintained, we've tapered the edge of the cutter face to give it the robustness needed to survive while drilling through interbedded formation transitions. And really combined, it's these features are able to work together to ensure that Stratablade bits can deliver on the improved drilling performance that customers prefer to receive, while still maintaining the durability that they require to both achieve and even exceed their footage objectives.
During the development process, the new drill bit was field tested in the Marcellus Shale and showed good results. Can you give us a brief overview of that project and what you saw in terms of ROP gains?
Yeah, absolutely. So, our testing program with all of our shaped cutter technologies, it really follows quite a similar path for each one. So first, we conduct extensive lab testing to verify that the cutting efficiency requirements can be met. Then the lab testing moves to a stage where we validate that the mechanical integrity objectives are also met to give us the confidence that the cutter will continue to survive when placed into downhole drilling environments. And really only when all of our lab testing objectives are fully met and completed are we really prepared to take the technology to the field and expose it to a customer's drilling operation. Now, what was great about the field test in the Marcellus Shale play was that it gave us a great opportunity to further validate everything we had already learned and confirm in the lab environment with a real-world drilling application. The application details made it a perfect fit for testing Stratablade in that the formation consisted of medium strength shale and sandstone rock types. And given the nature of our customer's drilling operation using pad drilling techniques, this meant that we would have the incredibly close offsets for comparison after completing our testing. Now, the benchmark bit prior to introducing Stratablade was an axe blade designed from Smith Bits, which had actually been performing very well for our customer. But they were curious, how could we further increase ROP for them? We proposed Stratablade and were able to test against offsets with nearly identical drilling conditions. The pad configuration meant that the intervals and formations being drilled were the same, and the only change we made to the PDC bit design was to swap the axe cutters for Strata cutters. The results clearly showed that Stratablade delivered on our drilling performance and cutting efficiency targets. When we reviewed the recorded drilling data, we could see that the Stratablade bit was able to increase ROP by 10 to 20%, while the rig was applying either the same or less weight on bit. And this is the literal definition of improved efficiency, where we are able to achieve a higher performance outcome as measured by ROP, while inputting less energy into the drilling system with lower weight on bit. The Stratablade bit was able to deliver the best ROP on the drilling pad while drilling the shoot-to-shoot performance that the customer required. And with results like these, our already high confidence in the product continued to increase, allowing us to duplicate this sort of performance in other basins in the US and internationally.
What do you see in store for future development of shaped PDC cutting elements? What can operators look forward to in this space?
Yeah, I really like this question because, at Schlumberger, there's really no doubt in our minds that shaped cutters are here to stay and will be a big part of the development process for PDC cutters going forward. The best part about using shape in PDC cutters is that it doesn't mean we forget about the development processes of the past, but those also get to continue along in parallel of exploring what are the ideal shapes for improving PDC cutter and bit performance. So while I expect we will continue to develop new geometries, much of our effort right now is focused on pulling those more traditional levers of cutter development to ensure that the wear and impact ratings of these cutters continues to improve. If we look at the drilling industry as a whole, we're really quite good at pushing products to their limits to maximize performance. But this eventually exposes weaknesses, which must then be improved upon so the cycle can continue. And the same will be true for shaped PTC cutters. We've already seen this with our axe blade products, which were initially launched back in 2016. So while axe blade has been incredibly successful at improving drilling performance in hard and brittle rock types, our experience gained as a result of reviewing tens of thousands of bit runs showed that it could be further improved as the drilling environments continually evolved. When we introduced Axe Ultra in March of 2020, this was the result of our efforts to improve the diamond materials while keeping that proven ridge-shaped geometry the same. With Axe Ultra, our axe blade products suffer less cutter wear and impact damage, allowing our customers to drill longer intervals while sustaining high levels of ROP. And this process will likely need to be repeated for all of our shaped cutter technologies in the coming years. Lastly, I'd just like to say, as an industry, I don't think we really should be debating on whether shaped cutters are necessary or whether they provide value. We should really be making sure that we always consider shape as one of those key performance metrics to enable PTC bits to continue to improve drilling performance for our customers around the world.
Well, thanks again for speaking with us, Mr. Long. We appreciate your insight on this topic.
Great to be here today. Thank you, Stephen.
This interview is a complimentary piece to a story from Schlumberger on its 3D shaped cutters in the March-April issue of Drilling Contractor. Please be sure to check out this story and other stories in either the print or digital versions of the issue. Thank you very much for visiting Drilling Contractor.